So in 11.2, we get into what's called polynomials. Poly kind of means many terms, but they actually categorize a monomial, binomial, and trinomials all under the same category. As far as a polynomial goes, we've talked about terms. So a polynomial is going to involve terms. But as we look at these terms, when we look at the exponents, there can't be any negative exponents. All the exponents have to be, again, we're talking about with respect to the variable, all the exponents of the variables have to be positive or non-negative, I should say. They can't be zero. But also what we pick up on is there can't be any variables in the denominator as well. So if we see any negative exponents involving the variable, or if we see the variable in the denominator, that's going to be a signal that it's not a polynomial. A polynomial it's going to basically be where your variable has to have what we call whole number exponents. Okay, that's going to be what we're looking for. So they have like 5x squared plus 3x plus 2. Notice that each term, the exponent here is a 2. The exponent on the x here is a 1. The x kind of falls off the problem here because when you have x to 0 is actually just 1. So that's how the exponents will always count down: 2, 1, 0. There's always a countdown when you're dealing with polynomials. Okay, so notice how 5x minus 3 over x, notice how that x is in the denominator. This is going to tell me that this is not going to be a polynomial. So this one was, this one's no. And notice how this x to the negative 2, notice how the variable is raised to a negative exponent. That's also going to tell me this is going to not be a polynomial. Oops, missed the 9 though. Notice the 9 has an x to 0 there. So it's okay to have the variable with a 0 exponent. We just don't even show it. A lot of times this is just written as simply 9, or we call that a constant. So when you have a constant, the variable's there, but since it's raised to the 0 power, we don't write it. So we have these words monomial, binomial, and trinomial. So these are our special names that we get into. Mono kind of means one, so a monomial is going to be a one-term expression. Now, the thing about terms is a term, everything is going to be connected by multiplication. So notice how we have a 3, that's fine. Negative 2x, that's fine. 5 times a times b, that's fine. 7 times x times y squared, because remember, y squared represents multiplication as well. That's fine. 3 times a squared over 4. Notice how we do have a fraction, but we are allowed to have numbers in the denominator, just not variables in the denominator. So these are all examples of what we call monomials. A binomial means we're talking about two terms. So we get into two terms. This is when I start using my little circle method to mentally see them. So when I circle the first term. When I circle the second term, I include the operation with it, and that's my two terms. So I see an x and a 3. Those are my two terms. So therefore it's called a binomial. So if I have this here, notice how there's a 2x and there's a negative 5x. That would be an example of a binomial, and that would be the two terms. Here we have x and this y over 4. Notice again, there is a fraction, but it's not a variable. So that'd be an example of a binomial. So a trinomial has 3 terms. Again, terms are connected by addition or subtraction. So notice how there's addition and subtraction present. So a is my first term. Again, I circle the operation to see my second term, and I circle the operation to see my third term. So a, b, and c are my 3 terms in my my trinomial. Notice how there's an x squared, there's a negative 3x, and there's a 4. Those are my 3 terms, and therefore we call that a trinomial. So here we have an x, and we have a positive 2a over 7, and we have a negative 5. Those will all be examples of trinomials. We probably won't be looking at all of these different varieties. We're going to probably keep it pretty simple with one variable for the most part. Most of ours won't involve 2 variables or 3 variables. It'll mainly just be x for the most part. So as we move into this expression here, notice how we have x squared y is one term, and the -1 is the other term. So this would be an example of a polynomial, and we would call that a binomial. So look at this next example. Notice how 4 and x minus 2 are connected by multiplication. So these are factors. So that would also be an example of a binomial. I'm sorry, a monomial, since there's only one term. Now, if I did some work on it, I actually could make that into a binomial, but we're not doing that at this time. If we look at the third one, notice how there's a y in the denominator. This is not a polynomial. Then if we look at this last one, we do have a 3x squared, a negative x, and a positive 1. So there are 3 terms. That would be called a trinomial. Excuse me. So next thing we get into is what's called the degree of a polynomial. The degree. So to identify the degree of terms in polynomials, first off, let's talk about the degree of a term. The degree of a term that has only one variable will be the non-negative exponent. So if I have like 3x to the fourth, the degree of that is going to be the exponent of the variable. So this would be considered a 4th degree term. If I have this negative 5x, notice how the x has actually an exponent of 1. So the degree of the polynomial is the exponent of the variable. And since it's a 1, we would call that a 1st degree polynomial. So the other thing is the degree of a constant is going to be 0. So notice how 5 is called a constant. And remember, I can write that as 5x to 0. So notice how the exponent of the variable is actually 0. So a constant is considered a degree 0 term. Now, if I have more than one variable, this is where it's so tricky, is to find the degree, we actually have to add the exponents together. So that's how we have a 1 and a 1. So we have 1 plus 1 means we have a 2. So this is a degree 2 term. Notice how here we actually have a 1 plus a 2. 1 plus 2 makes this a 3rd degree term. So hopefully we don't have to deal with those, mainly just deal with the ones with 1 variables. So if I want to identify the degree of each term of the polynomial, what we do is I use the circle method, and I just kind of pick up on these pieces. So notice that the term 5x cubed, the exponent was a 3, so 5x cubed has a degree 3, or 3rd degree. Our next term, notice how we have this 2x squared here. 2x squared, notice how we have a power of 2, so that's going to be considered a 2nd degree term. Negative 3x, remember, x has an exponent of 1, so that has a degree 1. And the 3 here on the end is a constant, and constants have a degree 0. So some other things to pick up on is special names. So the constant term is going to be the degree 0 term. In other words, it's going to be the number. A linear term is going to be a degree 1. In other words, the x is raised to the power of 1. A quadratic term is going to have a degree 2. In other words, x is raised to the power of 2. A cubic term is going to have a degree of 3. The other thing we want to pick up on is the degree of the polynomial that has only one variable and only positive exponents. We should say positive integral exponents is the degree of the term with the largest exponent. That's a mouthful. So what that's saying is if you have a polynomial that has a bunch of terms in it, what we're looking for is the largest exponent of the term. The term with the largest exponent will be the degree of the polynomial. So if I want to identify the degree of the polynomial, what I want to do is identify the degree of each term. And then I want to compare the degrees of each term of the polynomial and select the greatest degree as the degree of the polynomial. That's what I was trying to get out a minute ago. So if I look at these examples here, Notice how we have the 5x to the fourth is my first term, 2x is my second term, and -1 is my third term. So the degree of the first term is a 4, the degree of the second term is a 1, the degree of the last term is a 0. So the degree of the polynomial would be 3. If I look at this one here, we have 3x cubed, we have -4x squared, we have a positive x, and a -5. So we have a 3, 2, 1, 0. So notice that leading term, the front term, that is going to be our degree. That's going to be a degree 3. So since there's only one term, remember the degree of a constant is simply a 0. And this is just a linear polynomial, or we would call that a degree 1 polynomial. That's a degree 1. So remember, that's also described as a linear polynomial. So the third one there, that's actually called a cubic polynomial. Or we call that the cubic term as well. So another thing that's important to do with polynomials is make sure the polynomial is going from largest exponent to smallest exponent. When we do this, this is going to create what we call the leading coefficient, and that's going to be kind of nice for us. So when I write this as 6x, the 3x cubed would be the highest degree. The 6x squared would be the next one. The 5x would be the third one, and then the -7 would be the last one. By doing that, you kind of see that the degree of the polynomial is 3. So I want to identify the degree of the polynomial, which is 3. The leading term is going to be 3x cubed. The leading coefficient is going to be the 3 out in front. So if I look at this example here, x to the fourth minus 2x plus 3, notice it's already in the correct order. The degree of the polynomial is a 4. The leading term is going to be the x to the fourth. And the leading coefficient is going to be the number in front of the x. So remember, for that, it's going to be actually 1x to the fourth. So that means 1 is going to be our leading coefficient. Notice how this is not written in the correct order. I have to write that as 2x plus 4. So notice that the degree is the degree of the exponent of the variable, which is a 1. The leading term is the 2x, and the leading coefficient is actually just the 2 itself. D is written in the right order. Again, its degree is the exponent, which is a 2. The leading term is going to be the x squared, and the leading coefficient is the coefficient in front of the x squared, which is actually a 1. So next we'll get into is what we call basic operations. So I'll do that in the next video.